Micronucleus high-frequency pulse heating technology makes EV batteries more durable in winter. Is it difficult to start an electric vehicle in winter? Does the charging time of electric vehicles increase in low-temperature environments? When driving in winter, if you want to accelerate, but the vehicle seems powerless. With the booming development of the new energy industry, electric vehicles have begun to enter thousands of households and become increasingly common. However, every winter, the above-mentioned problems become the main problem that troubles most car owners, especially for users in northern China, where such problems are particularly prominent but difficult to solve. Why are electric vehicles not durable in winter? In daily life, people often encounter situations where they are eager to go to work or in a hurry in the morning, but their vehicles are unable to start for a long time. Charging the vehicle overnight, even though it is already fully charged, it still loses power quickly and is not durable. When driving on the road, I want to overtake, but my car is still weak. Roast like this can be found everywhere on the internet. So, what is the reason why electric vehicles are not durable in winter? In fact, the durability of batteries in winter is mainly related to their working principle. The function of a battery is to chemically convert the input current through the active substances of the battery, converting it into storable, chemical energy for storage. When the electric vehicle starts, it converts the chemical energy into the required current to release, and this working state is charging and discharging. Currently, most pure electric vehicles on the market use lithium batteries. When the temperature of the battery is below the normal operating temperature range, the viscosity of the battery electrolyte increases and the activity of the positive and negative electrode materials decreases, resulting in an increase in internal resistance when current passes through the battery, which reduces the available capacity of the electric vehicle battery. The experiment shows that when the environment is below 0 degrees Celsius, for every 10 degrees Celsius decrease in temperature, the internal resistance increases by about 15%. Therefore, the user's intuitive feeling is that the battery has a shorter discharge time in winter and consumes electricity quickly. In addition, lithium-ion batteries consume electricity quickly and are difficult to charge in winter, which is another important reason. We know that during charging of lithium-ion batteries, lithium ions detach from the positive electrode and embed into the negative electrode. But when there are some abnormal situations, such as insufficient lithium insertion space in the negative electrode, excessive resistance of lithium-ion insertion into the negative electrode, and the rapid detachment of lithium ions from the positive electrode but unable to be equally embedded into the negative electrode, it will cause lithium ions to form metallic lithium elements on the surface of the negative electrode, which is the lithium precipitation phenomenon. This phenomenon not only affects battery capacity, but also affects charging speed. In low-temperature winter environments, lithium precipitation becomes more severe. Therefore, after completing winter charging, the seemingly full charge is actually virtual charge. In actual use, it shows slow charging and rapid residual blood. In summary, both fast power consumption and difficult charging are caused by low ambient temperature. To restore the battery to its normal working state, battery heating technology is required. Currently, most of the commonly used battery heating technologies in the industry use external heating methods, with mainstream ones including PTC and heating film heating, as well as liquid cooling circulation system heating. The former is like labeling a warm baby on the battery pack, but it can easily cause uneven heating and the actual heating efficiency is not high. The latter is equivalent to installing a set of heating on the power battery, using heat pump air conditioning to forcibly extract atmospheric heat and convert it into the car. However, when the ambient temperature is too low, the heat pump is prone to failure. Therefore, some manufacturers have made magic modifications to it, not only extracting external air heat, but also collecting waste heat generated by the power battery system, drive system, and PCS power electronics to improve the overall efficiency of heat pump air conditioning, but the structure is relatively complex. So, is there a win-win solution? The answer is yes. The Chang'an Deep Blue SL03 adopts micronucleus high-frequency pulse heating technology. It is a new generation of battery self-heating black technology that Chang'an Shenlan has dedicated itself to researching and innovating, enabling vehicles to start normally even in ultra-low temperature scenarios of -30 degrees Celsius. This technology utilizes the characteristics of lithium-ion batteries where the internal resistance of the battery increases at low temperatures. High-frequency positive and negative switching of large currents does not cause lithium deposition, and does not affect battery safety and lifespan. Through random variable frequency IGBT opening and closing control, high-frequency pulse, and NVH balance control, a fast positive and negative switching of large currents is generated. With the help of the high internal resistance of the battery at low temperatures, joule heat is generated, thereby achieving fast and uniform self-heating of the battery. Micronucleus high-frequency pulse heating technology enables power batteries to withstand harsh cold conditions. There have been similar technologies in the market regarding battery self-heating. For example, BYD Qin Plus's hybrid dedicated blade battery uses two sets of lithium iron phosphate blade battery packs to provide direct current to each other for heating. For example, the battery pack of CATL also uses a method of heating the battery pack by allowing direct current to flow from the positive pole to the negative pole. However, this method of using direct current heating, due to the constant magnitude and direction of the current, is prone to the formation of segregation phenomena at the negative electrode of the battery, thereby affecting the charging effect and battery performance. A significant feature of the micronucleus high-frequency pulse heating technology used by Chang'an Shenlan SL03 is the use of alternating current instead of direct current. Because alternating current does not always maintain a constant value like direct current, it will always maintain a periodic change of positive value, tired face negative value, tired face positive value. It is precisely because of the non-constant characteristic of alternating current that it can reduce the burden on the negative electrode of the battery, thus avoiding the phenomenon of lithium deposition. In addition, Chang'an Shenlan has also strengthened the application of power semiconductor IGBT, insulated gate bipolar transistor. IGBT is a non-on, off switch that does not have the function of amplifying voltage. When conducting, it can be regarded as a wire, and when disconnected, it can be regarded as an open circuit. In addition, with the cooperation of the motor and BMS system, it is possible to achieve random high-frequency current charging and discharging switching, further reducing the occurrence of lithium deposition. Without the phenomenon of segregation, the battery of Deep Blue SL03 can be in optimal working condition for a long time. It is understood that even in an environment of -30°C, the micronucleus high-frequency pulse heating technology can quickly raise the temperature of the battery pack by 4°C per minute, shorten the charging time of the battery by 15%, and improve the power performance by 50%, effectively solving the problem of power degradation caused by battery performance degradation in extremely cold environments. It also solves the user pain points of electric vehicles, such as difficulty in charging, starting, and weak power in extremely cold and low temperature environments, a brand new electric travel experience for users. It is worth mentioning that in the specific use process of micronucleus high-frequency pulse heating technology, users do not need to start it in the car. They only need to remotely start the electric drive pulse heating function on their home phone, which can achieve short-term backup of the car, eliminating the anxiety of waiting in the car. They can get on the car and leave immediately, which is convenient and considerate. In addition, in environments below -10°C, this function will automatically start when the car is unlocked, effectively improving the winter driving experience. As China's automobile market gradually enters the era of electrification, traditional car companies and new forces are also showing a trend of fierce competition, which has made competition among car companies in the mechanical structure of vehicles, and high-precision and cutting-edge technology has become a key part. So, when Chang'an Shenlan launched the black technology of micronucleus high-frequency pulse heating, the performance of Chang'an Shenlan SL03 was also highly anticipated. We also believe that Chang'an Shenlan's technology can bring more surprises to users in practical use.